Hello everyone, in this video we're going to be solving Cambridge A-Levels Computer Science Paper 2. This is October-November 2022 variant 2-1. We're going to be solving this entire paper, so let's get started. Alright, so the first question is, an algorithm includes a number of complex calculations. A programmer is writing a program to implement the algorithm and decides to use library routines to provide part of the solution. State three possible benefits of using a library routine. So first we need to get familiarized that what is a library routine. So a library routine is basically like some pre-built code, pre-built code or some pre-written code that can be imported to your program and used. It's written usually by the manufacturer of the programming language, the IDE, or maybe it's written online and you're taking help or you're taking that resource that's free. There's just like someone else's code that you're using. It's technically someone else's code, or maybe it's pre-written code that you wrote yourself and you're using it over multiple programs. So we're going to be talking about the benefits of library routine. So let's go and first talk about the first obvious example that can come with a library routine. So first, it is easier to write complex programs without complex calculations. So let's say there is something that's mathematically related to your program, and you don't know how that math actually works, but you can use a library routine where someone who's good at math has written the program, and you can use that in your program to make complex calculations a lot easier. The next thing that can be is that the program is automatically updated, the library routine is modified. So basically, like if there is any change, like let's say there was an error in the math problem or that in the math calculation, the formula, if that's updated, then wherever you've used the library routine in your entire program, it's automatically updated. When you're working with bigger projects like Node.js, you're actually going to notice that it's actually the case that every of the programs are linked. So if you are updating your library routine once, it's going to be updated throughout the entire program. And lastly, library routine makes your code smaller or shorter. So library routines make the program smaller. Because obviously writing less codes is going to make your code a lot smaller. Let's move on to the next question. The following pseudocode is part of a program that stores names and test marks for use in other parts of the program. So someone has declared all of these. So declare name 1, 2, 3, declare mark 1, 2, 3. The pseudocode needs to be changed to allow data to be stored up to 30 students. Explain why would it be a good practice to store details in an array. So you can either use two 1D arrays, you can use a single 2D array to store like the name and the mark together. It's up to you. So I'm going to be giving an explanation for the 2D array because it's a little bit more efficient, but it's also okay, and you can also refer to the Mars thing for the 1D array solution. So the student name and marks can be stored in a 2D array. So if you're using the traditional method the question has shown you, you have to declare 30 variables for name and for marks. You don't need to declare all those variables if you're using an array. So these are going to be the benefits if you're using a 2D array. You can also use a 1D array, like the 1D array for name and a 1D array for mark. The index number corresponds to the particular name and the mark, and it's going to be pretty much the same explanation that it's easier to search. You don't have to declare many variables. It's pretty similar. If you're not using a 1D array, a 2D array solution should also work in the exam. So let's go ahead and move on to the next question. So the next question states, the following pseudocode statement includes array references. Say the purpose of the count and give its data type. So count is going to be the index number, the index of an element. So the index of an element in the array, and obviously this is an integer of data type, like obviously you're going to be using integers for the count, so this is going to be integer. Okay, let's move on to the next one. Okay, the pseudocode statement in the following table may contain errors. state the error in each case, or there's no error if there are no errors in the pseudocode. Okay, so let's go ahead and take a look at the first example, or in the first one that they have given us. So if the first one says, if empty is over here, as you can see, right, it's an empty string, then. So what do you think that the error is here? So the arrow symbol in pseudocode language, all right, if you're using pseudocode to write or draft out your program, this arrow symbol represents an assignment. What you're trying to do is you're trying to compare the two values. Like if this is equal to this, then we're going to be doing a particular task, right? We're not assigning stuff to empty. We're not assigning an empty string to, let's say, empty. So this comparison is wrong. So over here, they would expect you to identify this error, and the correct answer for this is going to be that this is not going to be an arrow symbol. We should have used equal to. So we shouldn't use this. Okay, so status is num negative 23.4. So what is the issue with here? So if in is num, if you actually take a look at your insert, okay, so with the paper, you're going to be given an insert. And is num works with something that's a char. So it's is num. Then you are to put a string. So it can be any string. So you're to put a string over here. That's going to work. And this data that's over here, this is a real data value. Like this is a real number. It's a negative real number. And that's not possible. There's going to be an error in the function because the function is expecting a string. So negative 23.4 is not a string. Moving to the next one, x, then we're assigning string to num. So there is a number that's in the format of a string plus 5. Yes, this is true that if you're going to be having x over here and then string to num, and then you've got a number that's a string format, so and then you're adding 5 to this because you're converting it to a number itself, this is going to be, there is no error with this. So there is no error. Next one, y, again, string to num, 37 plus 5. So you cannot use the plus here. You got to do it separately. This function only takes a parameter as string. So there should be no operator. Oops, sorry. Or in a Moran scheme, they will have, I think they have described it as wrong operator, but this is more appropriate to me, and I would have written this in an exam. Okay, so moving on to the next question. A number system is being developed to help manage a car hire business. A customer may hire a car for a number of days. An abstract model needs to be produced. So what is an abstract model? Where we develop a program and then we take out the unnecessary bits in that program. So that's an abstract model. So explain the process of they've asked the question, explain the process of abstraction and state 4 items of data that should be stored in each. So the process of abstraction, necessary data. Item 1, so that should be stored in each time, a car is hired. So it's like you're going to be just giving stuff that the program should. Like in general, if you were to develop this program, it's up to you that what are the main things you think that the program needs to store in order for this to that the customer is hiring a car may be, hired for a number of days and stuff like that. So first of all, we want the details of the customer. So you want the input and the details of the customer. You want the details about the customer who is hiring the car. For item number 2, we would want to say the car details, what car the customer is hiring. So input the car details. Then again, the car may be hired for a number of days. So we can say the hire date, or let's say the hire start date or something like that. So I'll just write hire, not data, sorry, hire date. Hire date. And finally, we would want, like, let's say, So I hire a car, so you would obviously want payment from the person who is hiring the cars. So I would say input, or you don't need to write input, you can just write input or just write payment details. Because the customer will be hiring and, they would like to purchase the car, they would like to hire the car for a few days, so you're obviously going to be charging some, money. Okay, for part B, we would like to go ahead and let's say input car details, then like input, like this is the task that the program does to operation. So what does the operation stand for? Tasks. Now what we can omit from the first answer then is what we want to go ahead and do to the input section. So we don't want the input to be in the first option because they're asking for it in the second option. So no need for input, just write the details of the customer, details of the car, then payment details, hire date. You can also write return date, then you can also write cost of hire, payment details, etc. Different stuff. And then over here, we're going to be writing inputting the card details, inputting the customer details, stuff like that. I don't really know if there's a word with inputting, but this is how you're going to be doing it. Let's move on to the next question. Oh, this is a pretty big one. So it says a 1D array data of type integer contains 200 elements. Each has a unique value. The algorithm is required to search for the largest value and input it. Describe the steps that the algorithm should perform. Do not include pseudocode statements. Okay. Search for the largest value. So search for the largest value. So first we need to go ahead and assign an unusually small in a max. So I'm just going to call it max variable. Next, what we would like to do, so we can see that the algorithm, it contains 200 elements. So what we want, initialize. We can also say set up a loop. So initialize or set a loop for 200 times. Done. Next, let's say we're going to go ahead and compare. Okay, so the algorithm is going to, we just want to describe what the algorithm is going to do. Compare each element of with the next element and store in max. So if one element is larger than the other, it's going to be stored in max. And finally, we're just going to be going ahead and you just want to write these answers in a more of a paragraph format because that's what they're expecting in the exam. But if you do write in bulletins, it's going to be what? So this is just basically describing that the algorithm is going to be taking us a very small value for max. So if you were to write a pseudocode for this, let's say we had max as assigned to -1. And then let's say for I, I'm not going to write index there just for the sake of shortcut. For I index, then we've got an array of data. So let's say if data of I is greater than max. So the first element, let's say, is 20, which is greater than max, obviously, because obviously 20 is greater than 1. So max is declared as an integer of negative numbers, right? So obviously 20 is greater than, this is true. So the 20 is going to be stored in the max variable and so on. So let's say the next element was 19. So 19, is it greater than 20? No, it's wrong. Then let's say the next element was 17, is it greater than 20? Wrong. The next element was 31, is it greater than 20? Yes, then it swaps places. The next was compared, let's say the next one was 35, this compared with 31. Yes, again, they swap places. So this is something you're taking to look for. That's where you're going to be assigning a very unusually small value, especially a negative number, to max in order for this code to work. And then the loop is going to run 200 times, comparing each element of the array and comparing it with the next in order to go ahead and determine which one is actually the largest. Okay, let's move on to the next question. So the next question is, the following diagram shows an abstract data type representation of an ordered linked list. The data item shows in each node in a single character. The data will be accessed in an alphabetical order. The symbol null represents a null pointer. That means there's nothing after L. So we've got a start pointer that contains the index position of the first node, right? So this is going to be the start pointer that contains the position or the index of the first node. So this value right here, this is the node, this is a node, and this is an address to the node. So the start pointer only contains an address to the first node and then continues so on. And there's nothing after L in the list. So now nodes with the data A and K are added to the linked list. So we're going to be adding A and K. Nodes with the data J and L are deleted. So J and L are deleted. So we don't want these, but we want to add something to C. We'll add it before C. And it will be made in alphabetical order. So it's basically A, then C, and then K. And there's going to be no J and L out of here, obviously. So we don't want these in the linked list anymore. So what we want to do is, since we're going to be starting with an alphabetical order, we're going to be drawing an arrow. It can be curly. It's usually curly in if you're trying to go out and draw it in an exam environment. It's better to draw it curly, but you can also draw a straight arrow. They're not going to be deducting no marks for it. It's not a straight box, just forgive it. Okay, so then we put A. After A, our next element alphabetically is going to be C. So the linked list is going to be pointing to C. We point to the element itself, not the box. So you can just draw an arrow pointing to the element. It's usually done in the front of the elements. It's better you do it like this. But if you didn't do it like that, they're not going to cut your marks really. And then we want something like K. So we're going to be pulling this out to K. And then you're going to be drawing another box that was going to be representing the address. And then there's going to be no element after K. So we're just going to be going ahead and drawing the null pointer, meaning that there's nothing after K. These are omitted, like we don't even touch them because they're not necessary. They're no longer in my linked list. Let's move on to part B. The original data would have been stored in a 1D array in which each element stores a character. For example, okay, advantages, okay, we know the advantages of making changes described in part A when the data is stored as a linked list instead of an array. So, when the data is stored in an array, and when they're stored in a linked list, what's the advantage of a linked list over an array? So, firstly, the first thing that should become coming to mind is when you're using a linked list, it's a lot easier to delete the data because let's say you had the two 1D arrays that were representing this linked list. You really don't need to touch anything with the data. They can still be in the data array. But in a node array, you just need to go ahead and delete the address of that linked list. And that's it. Your linked list is updated. You have deleted a following element. So it's a lot easier to add or delete something from a linked list. So you can just write easier. So the next thing is linked order. In an array, if you really wanted to swap C and J, you need to take out J into a temporary variable, put C in J, and then write the temporary variable back to an array. This is a lot of hassle if you're working with multiple larger arrays with larger amount of data. So it's easier. There's no need for changing the data. So easily, all we can do is just update the pointer location, and that's going to be it to update a linked list. So it's a little bit easier than an array. Now, explain the disadvantages of a linked list over an array. So first of all, linked lists are way complicated to set up, declare, stuff like that. We need two arrays for node and for the pointers. And so since it's a little bit more complicated to set up, so it's like, so the first initial thought should be more arrays needed. So we can write more arrays needed as we... So that's a little bit of hassle with the linked list. Okay, so the next thing is a program will store data using a linked list shown in part A. Explain how the linked list can be implemented. So to implement the linked list, all you're going to be doing is first, we need... So by a particular pointer, what I mean is like if you had two arrays for pointer and node. So if it's 5, then it's going to be, let's say the node area has 1, 2, 3, 4, 4, and then 5. So it's going to be like pointing to the 5th one. So let's say the 5th one is our first, the 5th one is our first element. So it's going to be pointing like this. Then we can say an appropriate value. Okay, so an appropriate value is set for the null pointer. So for 4 marks, we've got 1, 2, 3, 4 points. So this should be a good enough answer, but make sure I'm writing it a little bit in a shorter way. You write it in a much more nicer and organized way during the exam time. Okay, so looks like we're into our first harder questions. So let's first go ahead and read through the question, and then step by step, we're going to be trying to solve through it. Okay, so program uses a 1D array of type integer. Array 1 contains 600 elements, and array 2 contains 200 elements. So array 1 contains a sample value read from assessment, which is 3 consecutive samples, and their average summarized, their average is stored into a single element in the array. So array 2, so since it takes 3 readings, is divided by 3. So array 2 only has 200 of them, because 3, 3, 3, so 600 divided by 200, and you just need 3, you can have 300 over here, so like 3 elements can be stored into one of them because it just has 200 elements, all right? So array 1 has 600 elements, array 2 has 200 elements. This is actually important, we're going to be needing it later on. Okay, so the diagram below illustrates array 1. Okay, write pseudocode for the procedure summarize. So procedure summarize will calculate the average of 3 consecutive values from array 1 and write it to array 2. This will repeat for all values in array 1. So we're going to be assuming for this question is these are already written arrays, and we just need to take the data and calculate with it. So let's go ahead and get started. So first, what I would like to do is I'm going to write procedure summarize. All right, and the program does not take any parameter values, so procedure summarize. I want to declare the variables later on, so I want to first start with my program. So I want to use a for loop in here because it's going to make my task a little bit easier. So for a for loop, so let's say for index 1, 2. Okay, so here comes the catch. Okay, so for index 1, 2, and then we've got to put the number. So if you put 600, the problem that's going to be arising from 600 is going to be an issue of the numbers of the elements of the array 200. Because what I want to do is I want to use the same index value for our array 2. Okay, so I want to use the same index value for the array 2. So now what I want to do is index is, if we go ahead and let's move it here to update this. So I'm going to call this index A. Okay, this is for array A, so I'm going to call it index A. So 1, 2. So now we don't need all 600 elements, because what we're going to be doing is we're going to be adding stuff to it. So let's say this is element 1, then you're going to be element 1 plus 1, that's going to be 2, then element 1 plus 2, that's going to be 3. So we want to do it like that because we need to add 3 consecutive values. So what we want to do is we're going to write 598 because we want 600 minus 3, which is going to give us 598. So that once we add, go ahead and add, we want to do 600 minus 2. If you do 600 minus 2, which is 598, if we add 2 to it, it's going to be 600. So it's going to be, we want to add element 598, we want to add element 599, and then we want to add element 600. And over that's going to be giving us to this. Now, the problem that next is going to arise with a for loop is you can also do it with a while loop. But a while loop is going to be making it a little bit complicated because you got to add the index up thrice, but you can totally do it with a while loop. So with the for loop, what you want to do is we want to use the step function. So step represents how many times it will increment. Since in for loop, you really don't have, like, in a for loop, if you use the while loop, like you could have done, let's say, index A and then index A plus 3. You could have done that. But for a for loop, you cannot do that. Now, I would have used a while loop for explaining this function, but I'm using a for loop because in the marking scheme, a lot of students who will be studying alone, in the marking scheme, it's done using a for loop. So I'm trying to explain the for loop. So step 3 means the amount of iterations in the for loop, right? So from 1, it's going to jump to 1, 2, and then 3. So it's going to jump to number 3. So it's going to be adding from 1, 2, and then 3. So it's from 1, 2, 3. Then again, so 1, 2, 3. So it's going to be jumping 3 places. So from index 1, it's going to be adding 3 to 1. It's going to become 4. 1, 2, 3. So it's going to start from the fourth index. After the fourth one is complete, it's going to be 1, 2, 3. It's going to be starting from the seventh index because fifth and sixth are already added. So that's the task of this step 3. Okay, make sure you remember that. It does show up in a few years here and there. So what I want to do is I want to write, let's say, sum, because I want to do an average, right? So sum is going to be the array, So what I want to do is sum, and then we want to add array, array spelling is incorrect. So array index A plus array, this should be array 1. So array 1 index A plus 1. Now, one thing that a lot of students will do, and I would have also done, and which is totally accurate, is you can directly name this an average variable and divide it by 3. You know what? Let's just do that. Let's just make the code smaller. So instead of writing sum, I'm going to write average plus array 1, then it's index A plus 2. So from the first element, it's going to be going down 2 elements. So it's something like first element, then it's going to be 1, 2. It's going to be adding this one. All right. So that's the task. And then we want to divide this entire thing. So just divide it by 3. This is totally fine. You can do it, or you can use a sum variable and then do the average, which makes it a little bit accurate and makes the program look a little bit neater. But it's totally okay if you do this. And then we're going to be doing it into, why do I keep hitting it? So array 2, right? Was it array 2? Yes, it's array 2. So array 2 is just going to be average, right? Array 2 is going to be average. Now, array 2 needs an index location. So what's going to be the index location, right? So we want to go ahead and declare something for that. So for the index location, I'm going to name it index B. And initially, I'm going to name as index B is equal to 1. Or assign it a value 1. So not equal to, assign it a value 1. And then index B is going to be assigned a new value each time something's written to it of plus 1 until it's 200. And it's not going to written more than 200, right? So that actually ends our for loop. We run through a loop and increment it thrice. Find the average directly, put the average into array B, increment the index for the array 2, not array B, and then it's just going to be end for. Some people like to write it as next index A or next index. It's totally fine. And then did it ask us to output anything? No. So that's pretty much the program. So it's going to be end procedure. End procedure. And over here, we want to go ahead and write declare. We want to declare index A, comma, index B as integers. You can do them separately. You can do them in a single line. You can declare different indexes. It's totally fine. Now, the average over here. Now, the average. Average of the middle. Now, the average, when you divide something by 3 or any number by 3 in general, 3 is not like, you're not sure that this is going to be a divisible by 3 number every time. Like the sum is going to be, like, you've learned, like the sum is going to be going ahead and being divisible by 3. It can be divisible by 2. It cannot be divisible by 3. So it can be a real number. It can be a decimal number. So what I want to do is for declare, I want to declare value Boolean. Oh, no, sorry, not Boolean. I'm really sorry. Declare value, Declare value as real, a real number. You can also declare as a float. It's not even an issue, but it's better to declare as a real. But you can also use it as a float if you really want to, because you really know that real is never going to be a negative decimal number. So float will also do the job. Okay, so moving on. So we got to study some pseudocode. So we're going to be studying some pseudocode for this one. The following procedural algorithm attempts to check whether a string is valid, like a valid email address. So we got to study this entire pseudocode. In an exam, I would recommend that you kind of go ahead and read through this at least once quickly, So you're going to do it. Part of the validation, okay, let's go and read the word. Part of the validation implemented by the line, if dots is greater than or equal to 1 and ats is equal to 1 and others is greater than it, then, so we got to find this line first. So right here, all right, let me just go ahead and try to highlight this here. This value right here. Then valid is equal to false. So it says if not, right? If not, that means if this condition turns out to be false, okay? If you're not noting it. So if this condition turns out to be false, then valid is going to be turning out to be false. So what does this not actually mean is that if this entire thing comes out to not, that means this is not true. This statement is not true. A lot of people will actually confuse this with the Boolean operator like not of something. So let's say not of true is going to be false. And I totally understand that. But what the statement over here is trying to make us understand is that if the inner condition is not fulfilled, that's when it's going to be false. Like this is turning out not the value that we wanted it to be. So if dots is greater than 1 and ats is equal to 0, then, okay. So if not this, then the value is going to be going ahead and being false. Okay. So what this is basically trying to make us explain that the condition is true. This condition is true. This condition is true if the bracket is equal to false. Right? This condition is true if the bracket is equal to false. So let's say that even though this program does have some sort of validation here, so I haven't read the entire thing, at least of yet. So if dot is greater than 1, ats is 0. That means there's no ats in the email address, like this at symbol, and no dot, there's more than one dot, then it's directly false. Else index is 1. So it's like, it's incremented every single time. We go ahead and, verify the entire string. Now, in string should be, so the in string over here is basically the email address that's being input to the program. That's the in string. So we want to go ahead and assess the in string. If ats is greater than 1, then valid is false. Otherwise, others is other plus 1. So there are multiple layers of validation. And if all of these doesn't work, then the final validation is going to be that if dots is not greater than or equal to 1 and ats is not equal to 1, because it at least needs to be 1, and others is not greater than 8, then we're going to be going ahead and getting a false. So state the values that would result in the condition evaluating to true. So what it basically means that if this is equal to false, and then if it's not it, that means it's going to be the valid is going to be turning out to be false, meaning that dots is actually less than 1, ats is not equal to 1, and others are less than 0. So what we basically want to write here is if dots are less than 1, ats is not 1, and others is less than 8. So that's when this entire condition is true and the valid is set to false. Otherwise, we don't go to this and we just return the true valid. Okay. Let's move on to the next question. Okay, so this part of the question involves us to use a trace table. So give me just a second and I'm going to be taking a screenshot of the trace table. Okay, so we want to go ahead and assess this trace table. Okay, so this is basically this question. I'm bringing it to the previous page so that I can take a look at the pseudocode and work with it. So is valid. So first, I'm sending the first letter of a capital L. So index is initialized to 1, dots is initialized to 0, ats is initialized to 0, others is to 0, and valid is initialized to true. Then what we want to go ahead and do is we want to start our repeat loop. Next char is mid in string index 1. So we're going to be first storing something in the next char. So that's the first letter. And then we're going to be going ahead And then we're going to be going ahead and moving on to case of next char. So if it's a dot, then dot is dot plus 1. If it's an it's at plus 1. And if at is greater, so none of these are happening. So otherwise, it's like others is others plus 1. So nothing is happening here, so others other plus 1 in case. And then we're going to, if dot is greater than 1 and at is equal to 0, then valid is still false. Dot is not greater than 1, at is still 0, so it doesn't comply. Else index is index plus 1. So we go and update index. Now you can actually go and update index on the next line. It's better, I think, to do it that way. You go ahead and update index on the next line. But again, space is a premium, so I think we're going to be sticking with this one. In our exam, make sure you kind of do that. So we're going to go ahead and start the repeat loop again until index is greater than length of int string. So you're going to be going ahead and repeat. And the next char is int string index 1. So let's go ahead and extract the next character, int string. So we're going to go ahead and extract I. And then I is again going to be another character that's going to be 2, and then that's when our index is still incremented. And then again we take Liz, so the Z, and then again it's 3, and the index is going to be incremented to 4. And then finally we get a dot. Now, once we get a dot, that's when we're going to be going ahead and going to the first condition of dot and increment dot, and that's it. We are going to be getting out of the case of, like it was just like if. One of the conditions is true, that's it. Like it's if, else if, else if, else if. So this is true, we get out of this end case. And then if dot is greater than 1, it's not greater than 1 yet, so it's still going to be index plus 1. So what we're going to be going ahead and doing is, let's increment index. And then we have a number 1. 1. Oh, I forgot to increment this index. So a number 1 is, again, still going to be giving me 5 over here. So five over here, then index is going to be 6. Then we again get to 2, others is 6, this is 7. Oops, I think I intentionally left a gap here. But others would have been blank here anyways. I think this is accurate. But yeah, this is accurate. 3, 7, index is been 8. And then we come to our next one, which is an at symbol. So we give that, no other count. But in the at section, we're going to be now putting a 1. We increment the index because dot is still less than, it's not greater than 1, it's just 1. And at is not equal to 0. So this still isn't implied, so we're going to be going to the index position once again. From the index position, so we're going to be assigning an error of false because we have 2 ats. Anyways, so then we're going to go ahead for big. Oh, why did I increment? Sorry. So I did make a mistake here. I have incremented this by memory. Please don't. Make sure you kind of read through the pseudocode every time. So B is over here. So this is where other is going to be incremented. 10. Here, again, our other is incremented with 11. And then here, our other is incremented to 11. And then index is incremented. And then we have another at over here. So another at. So initially the valid was true. So when this is an at, we're going to be coming to this point. At is at plus 1. So if at is greater than 1, then valid is automatically false. Then end it. So we get out of case. Valid is valid false. No, this condition is still not met. At is greater than 0, but dots is still less than 1, so it's not evaluated. So index is going to be still incremented. But now our valid is false. It's no longer true. Valid over here is false. So we are directly going to come to until, and you can see that our condition is valid is equal to false. So I can go ahead and kind of go down a little bit and see. So our valid is equal to false. We want that to be evaluating to kind of false. So in a general note, then we're going to be updating or outputting. This is going to be 2 because we need to increment at. This is going to be generally false. So this is going to be a trace table with our final answer being false. So that will be our trace table. And in the next part of this question, it says, state the value. Zoom in. State the value returned when is valid is using the expression shown here. So what did we get? What did we get as a result? What will be the return? We're going to be getting false. So, So this is going to be false. The value returned is going to be false. Okay, let's move on to the next question. A simple arithmetic expression is stored as a string in the format of value, operator, value. An operator character is one of the following: plus, minus, asterisk, or a slash. An arithmetic expression, example arithmetic expression strings. Okay, so this is the arithmetic expression. A procedure calculate will take the arithmetic expression as parameter, evaluate the expression, and output the result. So it can be a range wide of numbers that's input as a string. So it's our job to go ahead and kind of extract each of these numbers. So I'm going to be showing you my solution, and then we're also going to be going ahead discussing the marking scheme. Okay, so we can assume the stuff takes the arithmetic expression as parameter, evaluates expression, output a result. We can assume that it only contains single-digit numeric digits and a single operator. Value and value represent integer values. They will not be preceded by a plus or a minus. So assuming that people input the thing correctly. Okay, so we're going to be getting started with the problem. So outputs the result and as a parameter. So I'm going to call the expression in string. So it's going to be a procedure. It's going to be a procedure calculate. And then I'm going to name it in string, where this is a string value. And again, I'm going to be leaving a huge amount of space for declaration because I think that this question has been requiring a lot of repeat repairs. So now I'm going to use a repeat loop in this case. This is what I'm thinking in my mind. So from the operator, so this is a variable that I'll declare later on. I want to extract something, right? So in string index 1. So initially, I want to keep my index as a value of 1 because I want to extract the first character of index. So what I'm going to do here is then I'm going to go for if. So I want to determine that if the thing that I extracted. So the first character is obviously never going to be, like a. Let's just call it, what do we call it? Oh, sorry, like an operator. Yeah, sorry, I actually forgot. So if operator is not equal to a plus, or operator is not equal to a minus, or operator is not. It's going to be operator is going to be is not an asterisk, or operator is not going to be a divisions and a slash. Then Okay, this is a pretty big line. I want to write value 1 is going to be assigned value 1 and operator. Initially, I want to write value 1 as a value of, oh, sorry, not a 0. This is going to be a string. So an empty string. Do we have space in the next page? Oh, yes, we do have space in the next page. But I think we're going to be continuing the code in this page, just so it's easy for us. Else. So if one of this is true, like this is a plus, this is a minus, this is an asterisk, because the question has told us to assume that these are going to be the only operators that's going to be used in the program. Else, we're going to be writing, okay, so we're going to be writing something called operator found is equal to true. Now, initially, we are not going to be finding the operator value, what the operator is. So operator find operator found is going to be false. And then this is going to be end if. So we're going to be ending our if statements. And on the other hand, we're going to be updating our index right from this index plus 1. Like, let's say took the first value. This is neither of them, so it's going to be going ahead and so these are all going to be true for the first value. This is not plus, this is not minus, this is not asterisk, this is not the slash. Then we're going to be putting in a value, and goes for the entire number. Index 1 until, so I want to exit the loop until operator found is equal to true. Okay, now what about value 2? So we're going to be extracting value 1 until the operator. So let's say for 803, all right, from the question, we had 803 over here. So 803, so then it finds this, and then it goes into the, okay, so it is extracted. I want to compare it to my code. So over here, operator, it goes through it, and then it comes back, and it extracts operator, right, like this. And then it finds that its operator is equal to this. So one of them is true. That means since I'm using the OR function over here, just one of them needs to be true. As soon as one of them is true, that means this condition is not met. So it's not going to go to the first one. It's going to go to the else condition. In the else condition, it's going to be operator found is going to be equal to true. So as far as I'm seeing, my program is working. So once it finds the operator, it's going to assign it, and it's going to increment index, and then it's going to be terminating the loop. So the good thing about using a repeat loop is it has already incremented the index for us. So if you want to find value 2, all I can do is I know the index values up to this much. That means I know the length up till the operator. So just calculate or take or use the right function, the right built-in function. You can use the insert that's given with your paper and extract it from the right, going from the right side to the left side until this index. So let's say the total length is L and this length is, let's say, X. So the length of this much from the right side, from this side, is going to be L minus X. All right. So basically now my value 2 is going to be right in string so this is going to be length of in string minus my index. Now I want to go ahead and use case-of function for determining that whether my operator was a plus or a minus or an asterisk, and calculate the required value from that, basically. So we're going to be going ahead and doing it. So case of operator. So I'm going to use another variable, which is result string to num. So everything over here was a string up till now. So string to num value 1 plus string to num value 2. If it's a negative, we're going to just go ahead and just for making things easy for myself, I'm going to go ahead and copy this. Put a negative. Then for my results over here, this is going to be multiplication. It'll copy this a little bit later. So that's I wanted for division. And then it's going to be division. So it determines that what is exactly happening for each operator. If it was a division sign, then it's going to be this. If it was an asterisk sign, it's going to be this, and stuff like that. Now, the thing is, operator over here, when it was extracted, it was never changed, right? So operator was, let's say, assigned the value. Let's say operator was assigned the value plus, and then it saw that if the condition turned out to be false, so it didn't go to this, it went to else, but the operator value never changed. So the operator was a plus, minus, or it stayed like that. So easily we can determine the value of the operator, and that's stored in the result. So we can just go ahead and write output result, and that's going to be end procedure. And after all that hassle and all that hard work, we are going to be finally going ahead and declaring all our variables. Declare operator. Operator is going to be just a character, so we don't need to use it as a string. Then I want to declare index. I used capitalize, sorry. It's going to be integer. Declare operator found. So we actually used a Boolean value, so that's in Boolean. Declare char. So let's go and quickly go through the code once again. We first start with an index value of 1. Repeat, we extract a character. We check if it's a plus, minus, asterisk, or not. If it is not, we go ahead and assign it to value. That means we're making our first value. That's on the left-hand side. And if it turns out to be a plus, minus, division, or any of these operators, it's going to go to the else operator, which is going to turn true. And a repeat loop is going to terminate if operator found comes out to true. And obviously, index is incremented in the meanwhile. So index is going to give us the length of the first value plus the operator. And we know the length of the total string. So we can just subtract it from the right side and obtain the second value, which is our value 2. And we have done that over here, right here. So we have extracted from the right side the total length of the string minus the index, which had the first value plus the operator length. And then we use a case function. You can use an if function. An if selection statement or a case. We used a case selection statement. You can use an if. So using a case selection statement, if it was a plus, we would have added it. If it was a minus, we would have subtracted it. If it was a star, we would have kind of multiplied it. If it was a slash, we would have divided it. And then finally, we output the result. And make sure not to forget to declare your variables.